Hi, let's look at the lecture of Chapter 3, Part 2 on Big Data. Part 1 last week was dealt with, databases? This one, I'm talking about big data. So what we're going to try to do is, let's make sure we understand what big data is, why it's a challenge. So hopefully when we're done, you'll understand what data management is, some of the key terms, relationship to data management, little different functions, what are the processes, and a little bit of maybe some free software, at least non-standard software, uh, and then just ways I can store data uh, in relationship to big data. So what is big data? Well, basically it's just an extreme large complex data collection. Um, and of course it has the necessary software to manage it, the hardware associated with it, how to analyze it. Because today most of the existing systems, relational databases, they got the limits. Uh, when you most of you played with in some of the classes you've dealt with access. Well, access has size limitations. Then you go to SQL, then you go to go to MySQL, then you go to SQL, and each one of those has its limitations as to one, how much data it can store, how it can process it, how it can organize it. Um, but big data is to put together complex and systems to make that a little bit easier. Now, basically is some of the major characteristics. You've got volume. How much data am I talking about? How fast is that data changing? And how much of a variety is it? Because you think about different organizations, what types of things do you get access to? Here's just a quick sample of what kind of data that an organization could have, from documents to data to social media to different sensors in maybe a factory, images from media, uh, log files from systems. Who knows? Public data, how you deal with your taxes and your federal government and regulations and OSHA requirements, and then just archives of historical data. I want to keep track in case I get sued. I need to keep track of some of this information so that I've got it on hand. So an organization gets tons of data, and one database usually can't handle it. So now it's like, how do I organize data in such a way that I can utilize it to run my business? So some examples of how it's used, retail organizations, are looking at social networks, how different organizations are branding, who's their competition, advertising and marketing, how do I track comments on social media? I want to make sure that my ads and stuff are out there. What are people saying about my product? Hospitals, of course, medical records and data. So there's just tons of information that's hitting at each organization, especially if they get big enough, that needs a little bit different organization and running. So some of the challenges is, how do I choose what data to store, where to store it, how to store it, what nuggets are information, what would be important for the decision maker. Sometimes you just don't know, so you just got to play that game. How do I get value? And we said that information has value only when you can process it and change it. So I need to understand what value from the data that I've collected. Um, and then how do I protect it? How do I make sure that all this data I've got, how do I know that only the right people get access to it? Because I don't want to allow this access to happen. I heard the same thing last week with databases. Do I have to protect who can read and write to a record? The same thing needs to happen with chances of big data. Except now you got more data, potentially more different sources, and so of course more access that I need to make sure I know who get access to it correctly. So a few terms. You got data management, just a set of functions that define the processes in which the data is obtained, certified, stored. So just what's your processes in place to manage the data that you're collecting? Data governance is identify the people, what roles to ensure the data can be trusted. Who am I getting data from? And who am I giving it to ensure that the data that I'm getting can be trusted? So that's just an issue you got to worry about. Because data governance, they've identified 10 different areas that you need to, that they've identified need to make sure. But uh, as far as management is concerned, but again, it's how do I develop the data? How do I manage the operations, secure it? How do I reference it and make sure I've got master data and backups and warehousing it and document control and data management. So there's 10 major areas in data governance. So it is a big deal. Now, it's also driven by a number of factors for data management. I need to make sure I can meet external regulations, to make, especially from a financial standpoint, making sure that I don't release personal data. You see that on the news all the time, and all of a sudden somebody releases the wrong information. I think one just lately, it's just a simple text message to the people in Hawaii about a missile getting launched. Again, it's releasing sensitive information, making sure that I know how the decision making. Because data governance says, hey, I need to make sure business leadership are active in this process. So it isn't just a one person making the decision. There's a cross-functional team that are recommended to be put together: executive project managements, line business managers, data steward, a person that actually has responsible for the data of those critical areas. So somebody has responsibility for that data. Now, you always got to remember the data also has a life cycle. So it goes all the way from the time understanding what the requirements of what data do I need, to evaluating sources, to acquiring, to store it, to publish whatever data is, to access it, evaluate it, and eventually data gets old, and it doesn't necessarily is required. So I got to find a way. Do I keep it? Do I get rid of it? So big data has its own little life of its own. So now there's a couple of different ways you can store data. And one is a data warehouse, just a large database that collects information from many sources. And basically it extracts it, transforms it, changes. So data warehouse is just a very large database that collects all the different information. Give you an idea what happens. You've got tons of relational databases and stuff, and all that stuff extracts it and loads it into one huge database. So instead of having to go across all these different platforms, relation database, flat spread, spreadsheets, all that gets put in, it's extracted, transformed, put into a data warehouse so that you can query just one source versus you having to worry about all of this information. A data mart is just kind of a subset. It's used for small or medium-sized companies. I don't have as much data that's out there, so I'm just kind of a smaller subset. It has a specific area. The data might contain greater detail than a data warehouse. A data lake, stores everything. It pretty much saves all the data in its raw form and just stores everything. So that way, when users decide what they want, they can go in and choose it, modify it, make it, create its value. But it just pretty much, I'm storing any bit of information that's going across my network. Now, there's a couple of different ways. One is there's a NoSQL. We were talking about last week about SQL databases. Well, now there are databases out there that are NoSQL. So there's means of storing and retrieving data that is modeled, but it doesn't require a simple two-dimensional tabular array that was used in relational databases. The ability to spread data over multiple servers. I'm not required to have this predefined schema that everybody's got to follow. I've got a little more flexibility that can, provide improved access speed, maybe work on, improve a little bit of redundant information. So I make sure that I don't have all my data in one basket. Here's some popular, different types of non-SQL databases, based on the type of category. I want a key value, do I want a document, graph-based, column-based. Different tools offer different ways of storing that data. So you do have options. Now, there's a product called Hadoop that is a open source framework that includes several software modules, that includes storing and processing extremely large databases. Now it's got two components. It's got MapReduce, and it's got a distributed file system. So both of those are very important to this product. Just to give you a rough idea of its environment, here's everything coming from historical system, but here Hadoop says, hey, what happens if I'm running over 100 servers? I can cluster my servers and run it, and then I can back off and extract data and store it into either data mart or data warehouse. So it allows me to just stage the information, a bunch of servers, extract it, store it in the warehouses. So it just gives me a lot more flexibility and brings different data from different sources. So now, the one way of storing large databases is in memory. So it's a database management system that resides totally on your RAM. Now, random access memory definitely provides faster data rate storage on some secondary forms, enables big data and other problems, and it performs best on, definitely you have CPUs that have multi-core CPUs, but it at least supports everything in RAM, so you definitely got more speed than extra. So just to give you an idea, some of the manufacturers that do this. So hopefully that gives you a rough idea about big data. I know it's a lot, but it's just a smattering. Just know it's there, and hopefully you've got at least an exposure and understand what databases and big data is in Chapter 3. If you have any questions, you know how to get a hold of me. Have a nice day. Bye-bye.